Welcome students. Good morning everyone. Last session we had finished the topic called distance and displacement. We have started a chapter called motion in a straight line. Clear? It is also called motion in one dimension. In this last session we had finished a distance and a displacement topic. Done. I've told you already, go to our physics playlist in the same YouTube channel. From here, basics we had discussed. In the basics, all this distance, displacement, speed, velocity, acceleration, average speed, average velocity, all those things are there. Now, again, if I discuss the basics, I told you in the last class clearly, we will not be having sufficient time to discuss in detail concepts of motion in a straight line. So that is the reason, just to go through these basics, my dear students, as you have a lot of time with you now, go through those basics and that helps you a lot, right? Alright, so now today's topic is about speed and velocity. There are so many things to be discussed in speed and velocity. Speed, in simple words, a distance divided by time. In the last basics, what exactly meant by the speed? What is velocity? With the diagrams, illustrative examples we discussed. But now it's not required. Speed is a distance by time. Velocity is a displacement by time. Velocity is a displacement divided by time. Alright? Now, SI unit of speed is meter per second and SI unit of velocity is also a meter per second. Speed, as it is distance by time, so it is a scalar quantity. Velocity, as it is displacement by time, it is a vector quantity. Clear? Alright? Now, speed cannot be negative. It cannot be negative. But velocity can be negative, 0, positive. It can be only 0 and positive, but velocity can also be negative as it is a vector quantity, same like displacement. And the speed will always be greater than velocity. As long as the body is moving continuously, the speed is greater than velocity. Speed can also be equal to velocity when, as long as the body is moving in a straight line without turning back. See here, body started from A and reached to the point B and reached to the point C and reached to the point so on. It should never come back. If it comes back, speed will never be equal to velocity. I am talking about the magnitudes. Okay. So magnitudes of the speed will never be equal to the velocity magnitude. So magnitude is represented with the symbol modulus. Okay. Modulus. Modulus of the speed means the magnitude of the speed is greater than modulus of the velocity, magnitude of the velocity. Speed is always greater than or equal to velocity in terms of magnitude. So when it is equal, that is important. As long as the body is moving in a straight line without turning back, it is equal. Otherwise, it is always greater. Now, from here, last class we discussed speed by velocity will be greater than or equal to 1. Remember this. Okay? Now, most of the students will have the general confusions in conversion of the units. Especially when it comes to this topic, speed and velocity, conversion of units topic is very important. Look at here, 1 kilometer per hour. What is this kilometer per hour? It is the bigger units of the speed or velocity. So 1 kilometer per hour is equal to 5 by 18 meters per second. And from the same way, 1 meters per second is equal to 18 by 5 kilometers per hour. Is it all right, my dear students? Clear? Now, there are, see, when I talk about the speed, you should also consider that is a velocity. Simple. Speed and velocities are equal in magnitudes when they are moving in a straight line without turning back. So when I say speed, you should also imagine that the body is moving in a straight line without turning back. So that means that is also equal to velocity, right? So don't think that always sir is telling only velocity, what about the speed? Or he's only talking about speed, what about velocity? Don't think like that, right? That's the reason heading I have kept is speed and velocity, right? Here we talk about the direction, here we will not talk about the direction. Now, unit conversion is also done. There is a uniform motion. A uniform motion. What is this uniform motion? Body started from point A, reached to the point X. Here, time 0 seconds, position 0 meters. After 2 seconds, it is traveled 10 meters. After another 2 seconds, it is traveled, reached 20 meters from here. At 6 seconds, it is at 40 meters position, 30 meters position. Look at here. In this interval of 2 seconds, what is the distance traveled? 10 meters. In this interval of 2 seconds, see, what is the interval here? 2 seconds. In this 2 seconds interval, what is the distance traveled? 10 meters. In this 2 seconds interval, what is the distance traveled? 10 meters. So, what I can write? If a body is covering equal distances or equal displacements in equal intervals of time, we can say the body is moving with a uniform motion. What is that? Uniform motion. Okay, and this uniform motion is also called as uniform speed. Again, I am writing here. Uniform motion is also called as uniform speed or uniform velocity. No confusions, my dear students. Uniform motion is also called as uniform speed or uniform velocity. Means constant speed or constant velocity. If a body is moving in uniform motion, that does not means variable speed. No. If a body is moving with uniform motion, that means exactly that means it is moving with a constant speed, right? Or constant velocity. That's it. When the body is covering equal distances in equal intervals of time, that's called uniform speed. When the body is covering equal displacements in equal intervals of time, that is called uniform velocity. No confusions. Okay. Now, this is position. Y-axis is representing the position in meters. X-axis is representing the time in seconds. You know, this is the graph represents the body is at rest. Yes or no? See here. As the time is increasing, there is some position. There is some position. It may be some 10 meters, whatever it may be. From the reference point, body is at 10 meters. As the time passes, the body is maintaining the same position. That means it is not moving. And in the basics, graphs also we discussed. In the basics, the graphs we discussed in detail the basics. Higher level of the graphs you will be discussing in the another track of physics where basic mathematics is going on. This is the graph we have discussed. position time graph when the graph line is parallel to the x-axis, so that is indicating the body is at rest. Now let's concentrate on the uniform motion. That is our topic, right? So the same x-axis is time and the y-axis is representing position. Uniform motion will be represented here in this way. A straight line passing through the origin making slope with x-axis. This is called the uniform motion or uniform speed, uniform velocity graph. And a most important and commonly asked graph is, this is the position time graph. Okay. Now look at here. This is the graph line. What does it mean? Look at here. This is also representing the uniform motion graph only. But interestingly, the body is starting from here. It is not starting from the origin. That's it. When we started measuring the time at 0 seconds, the body is already at some position. That position may be 20 meters from the origin. If you consider a tree as an origin, tree as a reference point, from the tree, already the car is at 20 meters distance when we start counting our time. Here, when we start counting our time, the car is at the reference point or at the origin or at the tree, if the tree is your reference point. Here car is already moved some 20 meters. In that case, from a particular position, object is moving and moving with uniform speed. Moving with uniform speed. Okay, so this is also a constant slope, understand? So this is a constant slope and this is also a constant slope, my dear students, constant slope. And slope of position time graph, this we had already discussed. Slope of position time graph gives you speed or velocity. Speed or velocity, already we had discussed in the last basics. How to find the slope? That also I have told you. You go through that. Again, if we start, and it will be repetition of the basics. Alright? So when time to time, when the numericals comes, when the concepts comes, time to time we will again recollect the basics, but this is not an exclusive basic classes, and you go to the playlist and watch the videos, you will understand what exactly the exclusive basics we have given. Right? I hope most of the students have gone through the basics. Let's move on. This is about the simple concept of position time. So the graph concept will again come here. Their position time, velocity time, acceleration time graph in detailed as per your first PUC standards and NEET exam standards we'll discuss. Let's look at here. My dear students, we are talking about the speed and velocity. There is a concept called average speed or average velocity. What is that? Average speed or average velocity. Average speed, which is total distance divided by total time taken. Average velocity, it is total displacement divided by total time taken. Whenever I say average, you must consider the total by total, total by total. Here also the same thing. Average velocity of a body can become 0, can be negative, and can be positive. Average speed can never be negative. Understand? So because it is distance and this is displacement, it is a scalar quantity and it is a vector quantity. Okay, so when this average speed and average velocity relation, if you want, average speed is greater than or equal to average velocity. Always, if the body is moving in a straight line, this is also magnitude only, no confusions. And in the same way, a distance will always be greater than or equal to displacement. In this case also, this is magnitude, no confusions. Okay, clear? Now, average speed and average velocities. there are various cases related to average speed and average velocity that we will be discussing now. Average speed and average velocity, different cases we are going to check. But the basic definition of average speed or average velocity you should never forget. Average speed or average velocity I am just writing and representing with V suffix average. That may be average speed or average velocity, right? Let me take it as average speed. Total distance traveled by total time taken. And again I am reminding you, these classes are also comes under basics, and those basics we have already done. Average speed is equal to total distance by total time taken. Now let's take the first case. First case is so simple. The body started from point A and reached to the point B by covering in this way. x1 distance from here to here, x2 distance, x1 distance in a time t1, x2 distance in a time t2, x3 distance in a time t3. Understand? x1, this is x2 and this is x3. Right? From here to here in a time t3, from here to here x4 in a time t4, from here to here x5 in a time t5. See, total distance traveled is how much? x1 plus x2 plus x3 plus x4 plus x5. So average speed or average velocity will be total distance traveled by total time taken, t1 plus t2 plus t3 plus t4 plus t5. Average speed or average velocity comes into the same way. Now, second case. Body is starting from point A and reach to the point B. Total distance is xn. This x is divided into two halves, x by 2 and x by 2. Carefully see, x is divided into two halves. First half of the distance, the body is moving with a constant speed v1. First half of the distance. Second half of the distance, the body is moving with a constant speed v2. Alright? First half of the distance, it is moving with a constant speed v1. Second half of the distance, it is moving with a constant speed v2. So I am writing here v1 and v2 are constant speeds or velocities. Constant speeds or velocities. Now the question, simple, nothing mentioned about the time. About time they have not yet mentioned. See, about time they have not mentioned anything. Alright? Question is to find average speed or average velocity in this case. Average speed or average velocity, let's start with a basic definition. What is a basic definition? Average speed is total distance by total time taken. What is total distance here? X by 2 plus x by 2. When they have divided into two equal halves, let's talk about halves. Total distance, first half distance and next half distance divided by. So this is numerator, x by 2 plus x by 2. Denominator, total time. So total time, let me say, from A to half distance, time taken is t1. From here to here, time taken is t2. So I am writing t1 plus t2. We know speed is equal to distance by time, and from here what I can write, time is equal to distance by speed, yes or no? Time is equal to distance by time. sorry, distance by speed. Here x by 2 plus x by 2 is the numerator divided by t1, means time interval in the first half. That means t1. T is equal to what? Distance by speed. What is distance? X by 2. Speed v1. X by 2 by v1. So that will be x by 2v1. So that is t1. Again I am telling you, my dear students, here most of the students get confused. We need t1. T1 is time interval in between these 2 points. Time is equal to distance by speed. Simple. Distance is x by 2 by v1, right? So x by 2 by v1. So that will be x by 2 v1. Plus it is x by 2v2 denominator. Now average speed is equal to x by 2. If you take common in the numerator, that will be 2 here, divided by denominator also x by 2. If you take common, it will be 1 by v1 plus 1 by v2. So x by 2 cancel. Right? Here, carefully see. I am just doing cross multiplication. The complete 1 by v1 plus 1 by v2 I am taking to the other side. Look at here. So 1 by v1 plus 1 by v2, which is equal to this v average I am taking to here. So that will be 2 by v average, and this is the most important equation, my dear students. Most important equation. When the total distance is divided into 2 parts, so this is 2. When the total distance is divided into n parts, n equal parts, so this is n. Okay. When the total distance is divided into n equal parts, it is n. In each and every equal part, the constant speeds will be v1, v2, v3, v4, so on, vn. Okay. Now, if the total distance is divided into n equal parts, then you can write 1 by v1 plus 1 by v2 plus 1 by v3 plus so on 1 by vn, which is equal to n by v average, my dear students. Remember this. Okay. If the total distance is divided into 3 parts, 1 by v1 plus 1 by v2 plus 1 by v3 is equal to 3 by v average. If the total distance is divided into 5 parts, 1 by v1 plus 1 by v2 so on 1 by v5, which is equal to 5 by v average. You can solve how many number of questions in this way. Let's see. Let's take this one. From this equation, see, I'm writing here, from this equation, v1, v2 is the LCM here. So that is v1 plus v2 is the numerator of the left hand side, which is equal to 2 by v average. Okay. Now, from here, v average is equal to 2v1 v2 by v1 plus v2. This is when the total distance is divided into 2 halves. Okay. Clear? Now, third case, it's similar to this. A body is starting from point A and reached to the point B. Imagine a boy started from home and reached to the school with a speed v or v1. With the same speed, or let's say a different speed. From the school to home, he came with a constant speed v2. In this case also, the average speed will be 2v1 v2 by v1 plus v2. How? This is also the same thing, right? Imagine the total distance is x plus x. This is one x is moving towards the school, another x is moving towards house, towards home. Total distance is divided into 2 parts, first half and second half. In first half, the body is moving with a constant speed v1, and the second half, the body is moving with a constant speed v2. Second half of the distance, okay? When the total distance is divided into two half intervals, then the average speed is this one. Fourth case. A body is starting from point A and reach to the point B. Total time taken is T. Total time taken, time total. Now, in the first half of the time, the body is moving with a constant speed v1. And second half of the time, the body is moving with a constant speed v2. In this case, find the average velocity or average speed. That's a question. Okay. Now, let's have the basic equation or the formula of the average velocity. Total distance by total time taken or total displacement by total time taken. Here, no distance displacement values are given. But numerator we need total distance. From here, distance is equal to speed into time. Imagine this is the distance x1 and this is the distance x2. So x1 plus x2, that's a total distance by total time taken. In the first interval, time taken is t by 2. In the second interval, time taken is t by 2. Okay. Now x, what is x? X is equal to, x is distance. Distance is equal to speed into time. In the first interval, distance is speed into time. Speed is v1. Time is t by 2 plus. Second interval, distance is speed into time. v2 into t by 2 by t by 2 plus t by 2. Now the average speed or average velocity in this case will be t by 2 in the numerator. If you take common, it is v1 plus v2 by t by 2 in the denominator. If you take common, it is 1 plus 1, 2. T by 2 cancel and your answer will be v1 plus v2 by 2. It's so simple. Here 2 indicates that. Number of intervals of time, number of equal intervals of time. How many time intervals are there equally? 2 here. If the total time is divided into 3 intervals of time, 3 equal intervals of time, here you get 3. And here 3 velocities you get. If there are n equal intervals of time, and your average speed or average velocity is v1 plus v2 plus v3 plus so on vn divided by n. Alright, my dear students. Now, 2 formulas are very important. Average speed or average velocity is 2 v1 v2 by v1 plus v2. Average speed or average velocity is v1 plus v2 by 2. These 2 formulas are very important, and here this formula we use when the total distance is divided into 2 halves. Simple. They give v1 v2 values, substitute, you will get it. They give v1 v2 values, substitute, you will get it. And this is the equation we use when the total time is divided into 2 half intervals. Alright? Clear? Some basic numericals also you can solve from here. Well, my dear students, let's have a look at the basic numericals for this session. And next session, we'll be solving some numericals based on distance displacement, average speed and average velocity. Let's see the first question. A body is moving from A to B. The total distance is x. First 1/3 of the distance, it is moving with a constant speed 10 kilometers per hour. Second 1/3 of the distance, it is moving with a constant speed 20 kilometers per hour. Third 1/3 of the distance, it is moving with a constant speed 60 kilometers per hour. You can carefully see here. The total distance is divided into how many equal parts? 3 equal parts. Okay. Then average speed we need to find out, and you have the formula 1 by V1 plus 1 by V2 plus 1 by V3, which is equal to how many number of equal parts? 3 divided by average speed. So simple. Here you take 1 by 10 common. It is 1 plus 1 by 2 plus 1 by 6, which is equal to 3 by V average. Alright. 1 by 10. So here the LCM is 12 and the numerator will be 12 plus 6 plus 2, which is equal to 3 by V average. My dear students, I hope you understand the situation here. So 1 by 10 is equal to 1 by 10 into, this is 12 plus 6, 18, 18 plus 2 is 20 divided by 12, which is equal to 3 by V average. So 1 0, 0 gets cancelled, 2 1s and 2 6, and cross multiplication you do, you get average speed is equal to 18. Everything is in kilometers per hour. This is also in the kilometers per hour. Alright. What is the formula we have used there? 1 by V1 plus 1 by V2 plus 1 by V3 is equal to 3 by, that means N by V average. When we have to use this formula? When the total distance is divided into N equal distance intervals, there is no concept of time here, you see. When there is a concept of time comes, for that the formula will be V1 plus V2 plus V3 so on Vn by N. That's a when time intervals, when there are equal number of time intervals. Alright, see the next one. If a car covers 2 by 5th of total distance with a speed V1 and 3 by 5th of the total distance with a speed V2, then find the average speed. Total distance is x. Simple. 2 by 5 times of x is moved with the speed V1, and rest of the distance, which is 3/5 of the total distance, is moved with the speed V2. How to find the average speed? Here they are not the equal intervals. Even this formula also we have got from, even this formula or this formula we have got from the basic formula only. Average speed is equal to total distance by total time taken. Average speed is equal to total distance by total time taken. Total distance is how much here? 2 by 5 times of x plus 3 by 5 times of x divided by total time taken. Speed is equal to distance by time. Time is equal to distance by speed. Okay. Time is equal to distance by speed. Here distance is 2x by 5. Speed v1. 2x by 5 by v1, that is 2x by 5 v1 plus 3x by 5 v2. So v1 v2 values they have not mentioned. So that means your average speed will comes into in terms of v1 and v2. No confusions. Average speed or average velocity in this case, what you can take common in the numerator? So you can take common simply x by 5. Alright, x by 5 you can take common. X by 5 if you take common, what you get, it is 2 plus 3, it is 5, numerator one. Denominator also you can take x by 5 common. Here 2 by v1 plus 2 by v2. X by 5 cancel. What is there in the numerator? V average is equal to 5 divided by new denominator 2 by v1 plus it is 2 by v1 plus it is 3 by v2, right? Sorry, it is 3 by v2 here. Now 3 by V2. It's 5 by V1, V2 is the LCM here. It is 2V2 plus 3V1. When it goes up, so it will be 5V1, V2 by 2V2 plus 3V1. See, your average speed arrived in terms of V1 and V2 because they have not mentioned here. When it is divided into equal intervals, in this way you have to solve. It is not divided into equal intervals, with the general formula we have to go. See the question, read the question, whether it can be solved with the formula or a basic formula, application or a basic formula. Now, I hope you remember we have two formulas, V1, 2V1, V2 by V1 plus V2 and V1 plus V2 by 2. How the questions can be asked in a mixed way, especially in JEE exams, this kind of questions will be asked in a mixed way. Mixed way in the sense. This is the formula we use when the total distance is divided into two halves. And this formula we use when the total time interval is divided into two halves. Alright, my dear students? Right? Clear? Look at the interesting part. There is a body moved from A to B. The total distance is x. Okay? First half of the distance, it is moving with a constant speed 3 meters per second. First half of the distance. Second half of the distance, what happens, second half of the distance, time taken from here to here is t. Second half of the distance is divided into two equal time intervals. So whenever you found equal time intervals, immediately you should recollect this formula V1 plus V2 by 2. So for the second half, I can use V1 plus V2 by 2, which is equal to 4.5 plus 7.5 by 2. 4.5 plus 7.5 is 12. 12 by 2 is 6 meters per second. I am talking about this. Second half, complete average speed now it is 6 meters per second for the complete second half of the distance. And first half of the distance they already gave it is 3 meters per second. The question is find the average speed for the total journey from A to B. That is what the question. Okay. What is the average speed? Now you have two half intervals of distance. X by 2, X by 2. In this X by 2 half interval, body is moving with 3 meters per second. In this X by 2, the body is moving overall with 6 meters per second. So, total average speed in this case will be 2V1 V2 by V1 plus V2. Average speed here will be 2 into V1 is 3 into V2 is 6 into 3 plus 6, 9. So, this is 3 threes, 3 twos, 2 twos, 4 meters per second is the answer, my dear children. In this way, the basic numericals and little advanced numericals will be solving in the next class. All the very best. Thank you so much.